Hello students, welcome to my channel Study Hub. Today I will start the thermodynamics part 2. So let's start. So पहले हम सबको बोलते हैं जे please subscribe, share it, subscribe it and like it and give me comments.
अगर तुम लोग नए हो तो सब्सक्राइब करो, वो जो लाल वाला बटन है उसके साथ स्कैम करो या फिर महफिल जमाओ, मुझे नहीं पता, बस क्लिक हो जाना चाहिए।
So guys, let's start. Today I will discuss about the thermodynamical process. Thermodynamical process. Thermodynamic processes. Thermodynamic processes. What are the thermodynamic processes? The operations or actions. What is thermodynamic processes? The operations or actions that brings changes in state of system is called thermodynamic processes. Clear? So there are several processes. I will discuss the most important processes are there. First process is isothermal process. What is isothermal process? Isothermal process. Isothermal process. What is isothermal? Iso means same. Thermo means heat, temperature. That means temperature remain constant. That is the process which carried out. The process which carried out at constant what? Constant temperature. Constant temperature. Carried out at constant temperature. The process which is carried out at constant temperature is known as isothermal process. Okay. So in this process, in this system, in this process, what will happen? In this, that is delta T, change of temperature remain constant, that is 0. Okay, that is 0. So change of temperature delta T equals to 0 isothermal में. Okay, it is gas in gaseous conditions. Ideal also, that is delta E also 0, delta U 0. Okay, in case delta E by delta U equals to 0. In case of, in this case, if you this is the pressure volume, so just constant temperature, what will be the graph? At constant temperature, the graph will be in this way. This is the graph of the isothermal process. Okay. Next come number 1. Number 2 is isobaric process. Isobaric. Isobaric. Iso means same. Bar means pressure. You have run pressure. Same pressure. That is the process which is carried out under constant pressure. Under constant pressure. Constant pressure में जो process चल रहा है वही है isobaric process. Clear? That is here delta P in this case pressure constant, delta P equals to 0. Delta P equals to 0. This is the isobaric process. Clear? Same pressure. Also, that is this will be pressure volume. This will be change. This will be change. Isobaric process. In this case, pressure volume that constant pressure. Okay, isobaric. The volume in this case, this is the graph. Next come isochoric process. Isochoric. isochoric process. These are the thermodynamical processes. Isochoric process, the process which is carried out, that is at constant, name is what? Choric. It is thermal, temperature, burr, pressure. It is choric. That means constant volume. Carried out at constant volume. That is delta V equals to 0 out here. Delta V equals to 0. Okay? In that case, if this is vessel is pressure, this is out here. See, in this out here, you can also write in this way out here, the isobaric, isopressure, isochoric in this process. That is the same. In this way, volume will remain constant. This is in this way. The graph will be in this. Okay? In this isochoric process, the graph will be. Next, it is come adiabatic process. Here delta V 0, here delta P 0, delta T 0. Adiabatic means, adiabatic I have earlier discussed what is adiabatic system. There is no heat can flow in or out. It can flow in or out of the systems. Here, well, what is the wall? That is the wall in the system and the surroundings. Systems and surroundings, the wall, it acts. That is the wall resists to transport the heat between the system and the surroundings. Clear? Resists to transport the heat between system and surroundings. Okay? And this wall is known as the adiabatic wall. Okay? This wall is known as the adiabatic wall. Okay? Adiabatic wall. Okay? So in this case, adiabatic walls, here delta Q equals to 0. Okay? Delta Q equals to 0. Clear? So, what we learned out here, isothermic, isobaric, isochoric and adiabatic. Besides this, there are also the cyclic process also there. Reversible process, irreversible process. So also there. I will discuss the reversible and irreversible process also. In case of cyclic process, what will happen? That is, whatever may be the process that start out here, initial point, and final point is out here. It is cyclic process. In case of cyclic process, what will happen? I will discuss a little bit later. Okay? And also reversible process and irreversible process. Okay? So now, here you decide what will happen in case of cyclic process. Initial and final position, delta V, delta final minus delta initial. What you see in the cyclic process, what you see? In this case, delta T not equals to 0 because it is not the path function. But delta E, that is delta U equals to 0. Delta V equals to 0. Delta P equals to 0. All will be 0. But delta T, the delta Q not equals to 0. This is not equals to 0. Okay? in case of cyclic. Next, I will discuss about মুছতে মুছতে দেরি হয়ে যাচ্ছে, তুই কুকুদিলি না। State variable. What are state variable? State variable বা state function. State variable or function or parameter. State variables, state functions, state parameters. What are these? What do we know out here? The variables, the states of the gas. The state of the gas is defined by how? By the state variables. In the state of the gas is defined by the state variable. That is by pressure, temperature, volume. Suppose a gas is there. It is at particular pressure, particular temperature, and in this pressure and temperature it has particular volume. Suppose pressure is changed, temperature is changed, volume will be changed. So the states of the gas depends upon some parameters, some functions, some variables, which is known as state variables. Okay, the states, its referred state, it is up to initial state and final states. Initial state refers to starting by initial state of the gas in equilibrium condition, and final state after interaction with surroundings, that is the exchange of matter or energy, or both matter and energy, the system attains another equilibrium state, which is known as final state. In each and every case in a system, in the surroundings and system, there is a continuum giving pressure or temperature, and finally they attains the equilibrium state. So in case of initial, it is a starting state of equilibrium, and final after the interaction, it energy and matter both are interaction, and it is known as final state. The state function, I have told out here that the thermodynamic properties whose values depends upon only the state functions or variables. What is this state variables? What is state functions? The state functions, it is the thermodynamic properties whose values depend upon only on the initial and final states of the system. Initial and final state of the system. Okay, it depends upon the initial and final. In initial condition, initial, and it after something the system is final. The volume Vi or Vf, it depends upon the initial condition and the final condition. Okay, there is a state function. So what are the state functions? I have already discussed. So many functions are there: temperature, pressure, all of the functions are there. Pressure, volume, temperature, internal energy, enthalpy, entropy, Gibbs energy, all these are the state functions. So these are independent of the manner or way as to how the change is brought about. Okay, it is path independent. These are independent of the manner or way as to how the change is brought about. It is path independent. It depends upon the value of the initial and final. That is pressure, volume, temperature, internal energy, enthalpy, all these things. Okay. Suppose initial, final or initial energy of these systems A and now the system B is A Vi, final system is, so this Bf minus Bi, this is the system state function. This depends upon the final and initial. Okay, this is the state function. Okay, now come path function. Path function. Path. What is path function? Path function. Path function what? The function that depends on path taken to reach that specific value. The function that depends upon the path taken to reach on the specific value. Work and heat is the only two things very important, that is heat transfer. The required path depends upon the path, work and heat. Also, heat transfer, work is the path function. Work and heat, it is the path function. It is not the state function. It does not depend upon the state. Okay, suppose you are here and your friend is there. But this is my tutorial home. Tutorial home. You come to me to take your lessons, teaching for teachings. Say, this is your, and your destination is this. Now you have to come out here. You may come as a. You may come in this way. You may come in this way. Okay. So the path you may come. In this path you may come. Straight forward you may come. I will not bother about your coming. In which way you are come. You are coming in which way. Just you have reached my tutorial or study room. I will here to give you some lessons, and it is your destination, and you have to come out here. Anyhow, you may come here. That is your destination is out initial position, and this will be your final position. But this you come here and here. You come here and this may, if this consider, this is the path functions. If I will not bother about this is the state function. That is initial and final. तो initial तुम्हारे घर में हो, and it's my room. This is the final position, initial position. So it does not affect the path function. Required is work and heat is the path function. Okay. Reversible and irreversible process I will discuss, and it will be helpful for after next discussion. So I here discuss about the reversible and irreversible process. Reversible and irreversible process. Reversible and irreversible process. What is reversible process? What is irreversible process? In theory processes, one of the processes is reversible and irreversible process. In this process follow reversible path, and this follow irreversible path. This is ideal process and this is spontaneous process. This takes infinite time. A small, infinitesimally small, infinitesimal small. That is small process and small change. But it takes finite time. That is the opposing force and driving force, has very small difference. The difference of the opposing force and the driving force is very small. What is opposing force? What is driving force? I am discussing. Don't hear. But out here, large difference between the forces, opposing force and driving forces. Okay. Here, work done is maximum, but here work done not maximum. It is imaginary process. It is imaginary process. It is natural processes. Natural processes. Okay. It is imaginary. It is natural. Okay. It takes infinite time, the finite time, particular time. Okay. So in this case, here what you see, the process is carried out at infinitesimally through a series of steps. Infinitesimally, slowly, through a series of steps. Opposing force is infinitesimally smaller than the driving force. Okay. So these are the reversible and irreversible process. And next day I'll discuss driving force, opposing force, how it is, some examples of reversible, irreversible. Okay. So hello friends, hello दोस्त, hello बच्चों, लोड शेडिंग हो गया, क्या करो? I have to draw my ends out here, so please don't forget to subscribe it. Okay, please subscribe, share and comment. Okay, thank you, good night.
मस्त जोक मारा रे, या हंस रे हलकट हंस